This video will cover Part 2 notes of Trig 1.3 and Pre-Calc 4.3. So if you remember in the last video we left off talking about sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent is opposite over adjacent. So in this problem it says to find theta, so I want to figure out what the angle is. And then I also want to find the length of the missing side of the triangle. So I need to know this side of the triangle, which I'll label x. So if I'm going to find theta, my thought process is this. From what I have from this angle, that's the opposite side. This is the adjacent side. So with the fact that I have the opposite and adjacent, I can use the tangent formula. So I'll say that the tangent of my angle, so tangent of theta, is the opposite over the adjacent, so 15 over 8. Now because I'm trying to find theta, I'm trying to find the angle, what I need to do is move the tangent away and put it over here. And the way that I do that is I take the inverse. So you have a tangent inverse button on your calculator. So I want you to go to your calculator, find the tangent inverse button. It should be the same button as the tangent, but you'll just have to hit the second feature of your calculator. But make sure your calculator is in degree mode before you do this. So when you type in the calculator tangent inverse of 15 divided by 8, you end up getting the theta to be equal to 61.9 degrees. So that's my angle for this triangle. And again, this is a right angle. I should have had that marked on the diagram so we don't just assume. Okay, so that was the first thing it asked us to do. Then it says to find the length of the missing side of the triangle. Now, there's a couple ways that you could find the missing side. You could use Pythagorean theorem, which probably is going to be the best way for this problem because if I choose to use sine, cosine, or tangent, I've got a rounded answer here. I'm going to show you using sine, cosine, and tangent for two reasons. Number one, I think we can all use Pythagorean theorem pretty easily, but I want to show you how you would do it using these identities. So recognize that from this angle, the side I'm trying to find is the hypotenuse. You can pick what you want to use because you know both of these other two sides. I'm going to choose to use the opposite side and the hypotenuse. So that would mean I'm going to use the sine ratio. So the sine of my angle, 61.9, would be equal to, remember the formula is opposite over hypotenuse, 15 over x. Algebraically, to solve this, I have to get this x out of the bottom before I can figure out what it is. So the way I undo it, it's being divided, so I times. So this becomes x times the sine of 61.9 equals 15. And since this is being multiplied, to get rid of the sine, I divide by the sine of 61.9. So now in my calculator I'm going to type in 15 divided by the sine of 61.9. Again, I'm not going to use the sine inverse because I'm not looking for an angle. So when I use this tangent inverse over here, it was because I was trying to find a theta. I'm not trying to find a theta, I'm trying to find a length of a side of a triangle. So when I divide this out, I get 17. So x is 17. And again, just to verify, had you chosen to use Pythagorean theorem, you would take the two side lengths, add them up and square them. This would be 225, this would be 64, and together that makes 289. And when you take the square root of that, you get 17 also. So either method, kind of just draw a line here so you can see, either method is going to get you the right answer. Again, we were working with these trig identities, so I wanted to show you using the trig identities. You could also have done this using cosine because you know the adjacent side. I just chose to pick sine. Okay, so for my next example, it asks us to draw a picture to represent this scenario. So it says find the width of a river if you are standing 100 feet down the river from a point directly across from a tree on the opposite side of the river. Okay, so kind of confusing, so let's first think about this. This is my river. The question asks me to find the width of the river, so I want to find this distance here. Now it says that I'm standing 100 feet down the river from a point directly across from a tree. So let's say that there's a tree right here. I'm down the river across from the tree though. So I am down the river 100 feet. So here's me. And I'm across on the other side of the river down 100 feet. So this distance here would be 100. And the question says, from the point you are at, so from this point here, you are standing at a 50-degree angle to the tree. So this angle right here, from the point to the tree, is 50 degrees. And the question again says, find the width of the river. So I want to find this. So you've got your right triangle that you can deal with. Again, I know that this is a right triangle because it's I'm doing it directly across from the tree. So thinking about this, this would be the opposite side, this would be the adjacent, and this would be the hypotenuse. Now because I'm trying to find opposite and I know the adjacent, I'm going to use the TOA part of SOHCAHTOA. Or the of apples part of Oscar has a heap of apples. So I'm going to use tangent, in other words. So the tangent of my angle, tangent of 50, is equal to the opposite side x over the adjacent side 100. So to get the x by itself, it's being divided by 100, so all times. So in my calculator, I'm going to type in 100 times the tangent of 50, making sure it's in degree mode, and I get it to be about 119.2 feet. So I think the confusing part about this example is making sure that you get your diagram drawn correctly. Okay, the next question here says that you're watching a space shuttle from a distance of 2.5 miles away from its launch pad. So let's say that here is my space shuttle launch pad. Put a dot here, and we'll write launch pad. And I'm 2.5 miles away from it, so I am 2.5 miles. So I'm standing over here, and the question says, what height will the space shuttle be in order for you to tilt your binoculars at a 25-degree angle? So the space shuttle is here, and it is up in the air somewhere. And I want to know, what is this height when the angle, if I'm standing from here, when this angle that I'm looking up at it is 25 degrees. So that leads me to defining some vocabulary terms here just to make sure we understand. The first thing is we need to talk about an angle of elevation, and that is when you are typically standing on the ground and you are looking up at an angle. So when you're looking up at something, that's an angle of elevation. So this angle from the ground going up is an angle of elevation. An angle of depression is when you are standing on top of something. So let's say you're standing on the top of a building, maybe. So if you're standing up here, and it's the angle that you're looking down at something. So I'll just draw some arrows to show up. And this is the angle looking down at something. Okay, so if you think about looking straight out, going from the straight out horizon looking down, that would be the angle of depression. From the angle of elevation, it's the ground looking up. So here it's telling me that my angle of elevation is 25 degrees. And that's important that I put that in the right spot of my triangle, because if I don't, that's going to mess up my opposite and my adjacent, and it won't mess up my hypotenuse, but it'll mess that up. And if I get my opposite and my adjacent sides labeled wrong, then I can't use the right sine, cosine, or tangent. Okay, so I've got my right angle here. And again, the question is asking me to find this side, the opposite side, from the 25 degrees, when I know the adjacent side. So I know that the trig function that I have to use would be tangent. So tangent is opposite over adjacent, so tangent of my angle, 25 degrees, would be x over 2.5. And algebraically, to get rid of the 2.5, we would multiply. So 2.5 times the tangent of 25 degrees. Again, make sure calculator is in degree mode, would be about 1.2 miles. So the space shuttle would be about 1.2 miles in the air when you're looking up at an angle of 25 degrees. if I'm not quite sure if my answer makes sense, let's think about this for a minute. If this is 1.2 and this is 2.5 and I'm dealing with my triangle, I know that if that's 90 and that's 25, then the other angle in my triangle here would be 65 degrees. So because this side here is across from a 65-degree angle, and it's 2.5 miles, it has to be larger than the side that is across from the 25-degree angle. So if I came up with a number that's bigger than 2.5 miles, well, I know that answer can't be correct, because if this is the smallest angle in my triangle, this has to be the smallest side. So it can't be bigger than this side of the triangle. This is my second smallest side, so this would be the second smallest, or I guess you could say second largest, depending on how you wanted to look at it, angle or side of my triangle. And then obviously, because this is across from the 90, this would be the largest side of my triangle. So once you are doing a problem, think about the triangle that you have and ask yourself, does my answer make sense based upon the way that my triangle is set up? Smallest angle should be across from the smallest side, largest angle across from the largest side.